Now, architecture. We have some terminology. CDB, container database. The CDB is the database. It hosts the tenants, the pluggable databases. There's a bit of an issue with terminology here. I was on the beta program for 12c, and all through the betas, it was all called pluggable databases. But then just before 12c went GA, generally available, they renamed it the multi-tenant option. And you'll see a bit of confusion in various view names in the documentation between the words container, the multi-tenant database contains containers, a bit of a difference between the container terminology and the pluggable database terminology. Just be aware of that. So your container database hosts the pluggable containers, the PDBs. There is only one database in one instance. What does that mean? One control file, one undo table space. A 12c enhancement, by the way, you can have one undo table space per PDB if you really think you want it. As I just mentioned, one thread of redo, one set of background processes, and of course the SCN, your system change number, that's global. It increments universally as it does in a normal database. So there is one database, which begs the question, what is a PDB? If the CDB is the database. So a PDB, the pluggable database, the pluggable container, to use the current terminology, resides within the CDB. It doesn't have its own redo log. It doesn't have its control file. There's one shared undo table space. So let's begin to look at what's going on here. I've got an environment here, exit, and echo % Oracle SID %. I've set my Oracle SID to JW122. SQL plus / the sysdba. Right, 12.2 database, nothing special, pretty much created out of the box. If you look at $$ database in a release 12 environment, you will see that there is a column CDB. So select, I'll take name, DBID, CDB from $$ database. I'm logged on to a database called JW122, and it is a CDB. Right, it is a CDB. So, what are these PDBs? A critical view, $$ containers. $$ containers has one row for every container. I mentioned the terminology changed. Nowadays, we're meant to call them containers. There is another view, $$ PDBs. It's identical, right? But with the change in terminology, when it went from beta to production, we end up with some views being duplicated and some slightly confusing terminology. So $$ containers is the view I prefer to use. That has one row for every container in the CDB. Every container has a name. Every container may be open or closed, but it resides within the CDB. Now, a PDB resides within the CDB. It doesn't have its own read log. It doesn't have control file. Shared access to the undo table space. 12.2 has an enhancement there, but it does have its data dictionary. It does have a data dictionary in there. Now, with regard to what have I got in this database, I shall select name, open mode from $$ containers. And in my little demonstration system here, I've got 3 containers. CDB $root, PDB $seed, that's a pluggable container. And we'll talk about what these all are very, very soon, and the significance of the 3 different containers I've got here. A PDB has a dictionary describing its local objects. Now, it consists of a set of table spaces and exposed to the user as a database service. That's all a pluggable container is. All a pluggable database is a set of table spaces and a database service. Those of you like Chris who are working with, or well, those of you who are working with RAC will know all about database services. Use of services has been largely optional for many sites. It's going to become compulsory when you start using multi-tenant, because the only way to connect to a PDB, a pluggable container, is through a service. So the PDB is a set of table spaces exposed to users as a service. So let's look at my database listener. LSNR CTL status listener 122. Right, my listener running on that address, listening on that address, port 1522. And these are the services my listener knows about. There's a service called JW122 being offered by the instance JW122. There's the XDB service, but there's another one, JW122 PDB. There's also a pluggable container called JW122 PDB. What if I connect to that service? SQL plus system Oracle at. I'm not going to a TNS names file here, don't worry about that though. Address, port, and I'll ask for the service JW1222 PDB. JW122 PDB. Note, hosted by the instance JW122. So going through the listener, I'm now logged on to something. What am I logged on to? Right, show parameter name. I'm logged on to a instance called JW122, a DB name JW122. So what's the difference between that and this session here, where I said connect/assist-DBA? Remember my Oracle SID is that? There. And at this level, we'll see no difference. Instance JW122, DB name JW122. But there's a very big difference indeed when we start looking at the table spaces. From here, I'm within my pluggable container. I've connected to the service there, hosted by the instance there. Select star from $, table space. System, sysorgs, undo, temp, users, example, TS1. Those are my table spaces. Let's run the same query here. I'm seeing a whole lot more table spaces. We also see this column, con ID. Con stands for container. So let's take the query I ran previously a bit further. Name, open mode, con ID from $, containers. Every container in the CDB has a unique container ID. That thing, JW122 PDB, is container 4. And there we see, select star from $, table space. These are the table spaces that make up container number 4. Note that TS hash is no longer a unique identifier. Name of the table space is no longer a unique identifier. Container number 1 has a system table space. Container number 2 has a system table space. And this container number 4 has a system table space. Each container, each pluggable container, is a set of table spaces, including a data dictionary, that describes its local objects, exposed to the user's database service that you connect through Oracle Net. So that's the fundamentals of the architecture. One database, one instance, but within that one database, you have multiple sets of table spaces. Each set of table spaces is a pluggable container, identified uniquely by container ID. And each of those containers has its own data dictionary.
John, is there a benefit to having multiple containers? Is there some organization you're shooting for?
How would you group your containers together? Well, many sites are going to end up having multiple container databases, of course. You might well end up with a production container database containing your production databases, as containers, a development container database containing your development containers, a test database containing your test containers. That would not be an unreasonable, that would be a reasonable structure that might bring perhaps 30 instances down to 3. That would be a reasonable approach. The data files, I see that's in the question there. The data files are important. Let's take this a step further. Now, I'm just going to go ahead to the next slide. No, not quite yet. There's SQL Plus has a useful command, show con name. This session is connected to the container cdb $root. This session, show con name, is connected to the container jw122pdb. Useful SQL Plus command, show con name. You can also extract the same information, by the way, if you query syscontext. So you can find out your user environment through syscontext calls. So you can programmatically find out what container you're in. But your users and your developers shouldn't need to know. They've each got their own table spaces. Let's take it a step further and look at the data files. So I'll just take call name, format A, 80, select name or TS hash name from $, data file. Okay. Here we see in the container JW122PDB, these are the data files. Run a similar query here in the root container, cdb $root. Remember, the root container always shows you the entire picture. 3 containers. Container 1, container 2, container 4. And those are their names. When we look at the same query here, you'll see each pluggable container, container number 4, remember, is my pluggable container. Each pluggable container has its own distinct data files. There's absolutely no overlap between them. So the CDB contains many containers. The root container is the control structure. That's where you see the entire environment, such as all the data files, and can manage the entire environment, particularly undo, redo, and the control file. It also has what you might call the master data dictionary. It's got a data dictionary, a sysorgs table space, a system table space, I should say, living in that data file, that defines the Oracle supplied objects, all the Oracle supplied objects. The pluggable containers are logically separate virtual databases within the CDB. They have a local data dictionary, in this case contained in that data file. They even have a local sysorgs table space. In this case, I've enabled local undo, but that's entirely optional. It's a 12.2 feature. But they have their own data dictionary defining the locally defined objects. But they have access to the common objects that are defined here in the root. So that's your architecture.